I want to show that T of sigma prime nk, which I will just denote as T and K. Recall that this is mod P. Mod P, this maps onto 1, 1, K, L to the K, that this acts punctually on the image of HR gamma n minus 1p into HR gamma np by using the upper inclusion. Okay, so to do this, I will, let's call this IL and call the lower inclusion IR. Or let's just call it, all of this is bad notation, I, L, and IR. And we have already computed what how TNK acts on both of these. And so this would be acting on this would be IL of T and minus 1k zeta plus L to the n minus k times I L T n minus k, k minus 1 of zeta times the matrix 1, 1, 1, 1, L to the k minus 1, L to the k. And T and K on IR zeta is equal to L to the k times IR of Tn minus 1k of zeta plus IR of Tn minus 1k minus 1 zeta times the matrix L in L to the negative k 1, 1, 1, L to the k. Now I'm following the proof in Ash. He can assume that in a stable range, these two inclusions are just the same because you can go from one inclusion. So if you have gamma n minus 1, gamma n, I left, I right, then you can go from one to the other with a permutation matrix. And now I have to think what is the right, by conjugating with the right permutation matrix. And this would be the cyclic permutation, and I think it would be this cyclic permutation. So in particular, we also get this for the I star, and we also so we get that Tn k I star r is equal to, now I think I'm going to write it from the other side. Tn, or I'm going to write it like this, L of sigma times this matrix, and now we've seen that this matrix, I can pull out the permutation matrix with a suitable factor. Or rather, I have to conjugate this matrix with 1 through L to the k, which then gives me that this is I believe 1 through L1, L to the k here, and L to the negative k here, which is the same as 1 through L to the k, L to the negative k, times the original permutation matrix. Okay. Now here comes the trick that I'm using. I'm going to assume that zeta doesn't just, so zeta in originally was an element in HR gamma n minus 1 of R, NP. But I'm going to assume now that zeta is in fact an element in the image of gamma n minus 2. So I'm going to assume that in fact zeta is actually in the image of gamma n minus 2 to gamma n minus 1 with the inclusion of, with the left inclusion. This way, I can forget about all of these diagonal matrices that are being multiplied. So the point is that now I star L of Tn minus k minus 1 zeta times 1, 1, 1 L negative k L k is the same as the sum over z times s prime times 1, 1, 1 L negative k L k, where the s are in Sn minus 1 k minus 1, and thus the inclusion, this is all being included like this. Now, because mod p, and we did this argument yesterday, this is diagonal and this is diagonal. I mean, this really I should view as a matrix in SLNZ that is just looks like this mod p. I can pull this past and have this part act on z directly, but because z is only in this part, they commute, and so it acts trivially. So all I get is Tn minus k minus 1 of zeta. Similarly, for this, because the zeta now lives in here, it was originally through R, it's embedded in here, but I assumed that it comes from this part. This matrix acts trivially on the zeta, and it commutes past the t. So I get that this is also just this inclusion. And so, the same happens here, that I just get that this is this times that, but this acts trivially on IL of zeta, as we just see. So we get additionally that IR, that T and K of IR zeta is equal to Tn k of IL zeta times this permutation matrix. So now we're in business, because we can write the right-hand side as L to the k times I star R of Tn minus 1 k of zeta plus I star R of Tn minus 1 k minus 1 of zeta. And we can write the left-hand side as I star L Tn minus k of zeta plus Ln minus k times I star L Tn minus 1 k minus 1 zeta times the matrix times this permutation matrix 1, 1, 1, 1 here. And we've already said that if I multiply this matrix times something that comes from this inclusion, then that is the same as the right inclusion. And now this equation was used by Abner already, and we just get that LK minus 1 IR. Well, I wanted to do everything with IL, I guess, but let's try to see what's coming out when I do this with IR. Why not? This is Tn minus 1. So I pull this one over to this side. And I'll pull this one over to that side. Okay. And now I can do some induction where I start with, well, what is Tn minus 1 n minus 1? So k is n minus 1. We've discussed this before. Here we're just acting with the identity matrix. Actually, let's start with k equals 1. So then we get that, what do we get? We get the equation L minus 1 Tn minus 1, 1 zeta is equal to Ln minus 1 minus 1 times T n minus 1, 0 of zeta, which this part is just zeta because I act with the identity matrix, literally the identity matrix, not just something L times the identity matrix. And so I get that IR of Tn minus 1 zeta is equal to Ln minus 1 over L minus 1 times I star R zeta. So in particular, we get that Tn1 of I R zeta is equal to Lk, or L L1 times this bit plus this k minus 1 is 0, so just star r of zeta, which is in total ln minus 1 plus dot 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 plus 1 times I star r zeta, which is indeed the degree of Tn1. So I said earlier that I want to show that it acts punctually on the image of the lower of the left inclusion, and now I'm using the right inclusion. But remember that zeta, the zeta that I've chosen here, actually comes from the left inclusion from Rn minus 2 first. So it sits in the middle. It has a left and a right inclusion after another. So this is actually also the left inclusion of the right inclusion. So this is definitely not showing too much, because some part of the right inclusion will not act in the same way. So let's move on with the induction. And to do that, let me first say that Avner states in his paper that the degree of Tnk is Ln minus 1 times L to the n minus L dot 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 times L to the n minus L to the k minus 1. So k factors up here and also k factors down here. So it's basically the number of the inner Grassmannian. So L to the k minus 1, L to the k minus L dot 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 L to the k minus L to the k minus 1. Okay, so we already proved that Tn1 of I star of right inclusion of zeta is equal to Ln minus 1 over L minus 1 times I star R zeta, which is precisely dn1 times I star R zeta. So this is punctual. And now we want to prove by induction that this is true for all k. And to do that, we use this formula again that we already have, namely this is L times K well, what do I want? I want to actually first use this formula again and prove. So we have we proved that I star R Tn minus 1 1 zeta is equal to ln minus 1 over L minus 1 I star r zeta, which is dn minus 1 I star r zeta. So I first want to prove by induction that this is equal to, well, this is equal to ln minus k minus 1 over lk minus 1 and times I star r t n minus 1 k minus 1 zeta. And by induction, I'm assuming that that part is dn minus 1 k minus 1 times the inclusion of zeta. But from the formula, you can clearly see that this is the same as dn minus 1k. So the whole thing is this times zeta. And now we can use the formula for t and k, I star r zeta is equal to L to the k I star r tn minus 1k zeta plus I r tn minus 1 k minus 1 zeta, which is the same as lk times dn minus 1 k plus dn minus 1 k minus 1 times I star r zeta. And now let's see, let's do this completely, but you will see that this is the same as dnk. We can, both of these have the common denominator is lk minus 1 lk minus l dot 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 lk minus k minus 1, and we can factor out for both of them ln minus 1 dot 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 times ln minus lk minus 2. That is something we can factor out. And here on this side we get L, oh, and it starts with ln minus 1. That's what we can factor out. And on this side, we have lk times ln minus 1 minus lk minus 1. And on this side, we have extra this factor that we didn't have before. So lk minus 1. That's not right. We also have this times L to the k minus 1, because of each of these factors has one more. anyway, we can take these L to the K minus 1 factors and put them all in these factors here to get ln minus L dot 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 ln minus lk minus 1. And now here we get, we have one L left, so we get L to the N minus L to the K plus L to the K minus 1. So this cancels over L to the K minus 1 dot 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 L to the K minus L to the K minus 1 is equal to dnk. And all of these is always times I r zeta times I r zeta times I r zeta. So what we prove now is that T and K with K at most n minus 1 acts punctually on the image of IRIL of HR GN minus 2 to HR gamma n.